Hello folks, in this video we're going to take a more in-depth dive into the addition rule that we previously have talked about. All right, so if you recall in a previous video we said the addition rule was the probability of A or B, and it equals the probability of A plus the probability of B minus the probability of A and B. Okay, so in the particular section that we introduced this, we were dealing with disjoint events. So remember we said if A and B are disjoint, so feel free to check out the previous video on that. Then we said the probability of A and B equals 0, right? Okay, anyways, let's just get into some more examples of the addition rule. Nothing really groundbreaking or new here. For example, Pew Research tracks the behavior of online adults. Recently, they found that 79% were Facebook users, 24% were on Twitter, and 22% used both. What is the probability that a randomly selected adult uses either Facebook or Twitter? So what's going to be extremely important, folks, when it comes to finding probabilities is labeling your events. All right, what I mean by that is that we have two things that are happening. We have either Facebook user, which I will denote with the letter A for event A, or we have a Twitter user, which is event B. So the question is very clearly asking us to calculate what's the probability of A or B. Okay. Well, I'm just going to rewrite the formula. It's the probability of A plus the probability of B minus the probability of both A and B. Okay. So what does that look for us? The probability of A. What's the probability that someone uses Facebook? 79%. I'm going to write it as a decimal. 0.79 is the probability somebody uses Facebook. Plus the probability somebody uses Twitter, 24%. So that is a 0.24. Minus the probability of both. And that is 22%. So that's a 0.22. So if we go to our calculator here, the answer is 0.81. But let's verify that. If we go to our calculator, we take a 0.79 plus a 0.24 minus a 0.22. We get the 0.81. So 81% chance that we select a person that's either a Facebook user or a Twitter user. All right. What's the probability that a randomly selected person does not use Facebook or Twitter? Does not use Facebook or Twitter. Well, in this case, we're going to exploit the complement rule. You remember, guys, remember the complement rule? Right? And it said it was the probability of A complement was equal to 1 minus the probability of A. All right? Well, that's what we're going to do here, right? Because if we say that, hey, what's the probability that a person doesn't use neither? So a person uses neither. Okay? Well, using neither is the complement of using either one. That makes sense, right? So this is going to equal 1 minus the probability that they use either Facebook or Twitter. Okay? Once again, we're exploiting the complement rule there. The complement of using none of them is that you use either one of them. Okay? All right, so what is that? Well, that's going to equal 1 minus the probability that we use either Facebook or Twitter. Well, we've already calculated that in part A, so I'm just going to grab that answer. Okay, so we know that that was a 0.81. So therefore, our answer is 0.19. 19% chance that a person uses neither, right? And that makes sense. There's a 100% chance that you do combine, right? So if 81% of them are using either or, then the remaining out of 100% are using neither or neither, whatever you want to say. All right, some more examples here. What's the probability of rolling 6 or an even number? 6 or an even number. So let's start off with our event A is that we roll a 6, and our event B is that we get an even number. Remember when it comes to rolling a single die? Excuse me, that's what we're doing here, even though it doesn't say so. We're rolling a single die. Remember, you can land on either 1, 2, 3, 4, 5, or 6. So the probability of A or B, and I like to write my formulas just as a way of muscle memory, so I don't have to keep on looking it up. All right. So what's A? A is the probability that we roll, or event A is that we roll a 6. Well, what's the probability that we roll a 6? Well, how many total outcomes are there when we roll a 6-sided die? Well, there's 6. So out of 6, and then how many of those outcomes is exactly the number 6? There's only one outcome of a 6. So the probability we roll a 6 is a 1 out of 6. Next, plus the probability we roll an even number. Well, how many even numbers are there between 1 through 6? Well, there's 2, there's 4, and there's 6. So the probability we roll an even number will be 3 out of 6. And then minus the probability of A and B. So here's where we need to get into whether or not we have disjoint events or not. On a single roll, can I roll both a 6 and an even number? We can. And in fact, it's the outcome of 6, right? Because I need to be both 6 and even. 6 is even, so that is what we have here is a set of events that are not disjoint. But anyways, rolling even and 6 is the equivalent to rolling just a 6. Which we said before, that probability is 1. There's only 1 6 out of the 6 outcomes, 1 out of 6. Okay, so adding up those fractions there, when it's the same denominator, you just add up the numerators. So 1 plus 3 is 4. 4 minus 1 is 3. The probability we roll a 6 or an even number is 3 out of 6, or if you want to reduce it, a half. All right. In our last example here, we're just going to show how you can utilize the addition rule to solve for probability of A and B, actually. So suppose the probability of A or B is 0.40, 40%. The probability of A is 0.25, and the probability of B is 0.35. What is the probability of A and B? So at first glance, you may be thinking, oh, I need to do the multiplication rule. No, we can actually use the addition rule in this example. So the first thing we're going to do is let's write our formula. So the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. All right. Next, we're just going to fill in what we know. So we know the probability of A or B is 40%, 0.40, equals the probability of A, which is a 0.25, plus the probability of B, which is 0.35, minus the unknown probability of A and B. This is what we're going to solve for. So to do so, on my right-hand side of my equation, I'm just going to take a 0.25 and add to it a 0.35, and that's going to give me a 0.60 minus the probability of A and B. Okay. Next, I'm going to add my probability of A and B to both sides of my equation. And lastly, we subtract 40% from both sides of our equation. And so we get the probability of A and B equals 0.20, 20%. All right, so if you come across a problem like that, hopefully that will, get you going in the right path. I appreciate you guys watching the video, and I look forward to seeing you in the next one.